So this week we're going to start off looking at section 3.4. We're going to do 3 sections this week. One section we'll split it into 2 days. 3.5 is a little longer, so we'll chop it in half and do half each day. Hopefully we'll get a review day in at some point. I don't think we're going to get it in this week, but I think we should be able to get one in at some point. And we are going to do quite a bit of review when we get towards the end of the term for midterms. All right, so there's a couple different ways you can write the equation of a line. All right, I know we've looked at that. We didn't really talk about it a lot, but that's one way you can write an equation of a line. Has anyone seen that before? Y equals mx plus b.
Yeah.
Yeah. So if you've seen that, that's what we call slope-intercept form. A little different than what we're going to do today. Okay, we're going to look at what's called standard form.
And guys, when you see that, we talked about this a little bit the last time we met, which was a long time ago, but that word linear, what does that mean? Yeah, it's a straight line, right? So whether it's standard form, whether it's slope-intercept form, what's it going to look like? Well, it's going to be a straight line, right? When we graph it, it's going to be a straight line.
Okay, so it looks something like this. So what's in bold here, you want to write this all down. AX plus BY equals C.
Hey guys, so whatever's in bold up there, you want to write. So you have a blank to write standard form, then you want to write that whole thing. AX plus BY equals C, where A, B, and C are real numbers, and A and B are not both 0.
All right, so just to kind of make sure people know what that means. Real number means you can pick anything you want. You can pick a positive, you can pick negatives, you can pick fractions, you can pick decimals. You pretty much can pick anything you want. The only thing you can't pick is you can't say, well, I'm going to let A be 0 and I'm going to let B be 0. You can't let them both be 0. Because then you'd be wiping everything out. You wouldn't have anything left. So can somebody give me a number for A? Any number you want. 7. Okay. So I'm going to plug in 7 for A. So 7. The X just stays right where it is. Now, someone give me a number for B. Yeah?
14.
14.
Number with X and number with Y equals
And then someone give me a number for C. Chris? 6. There you go. That's an example of a line, if you were to draw it, and that's in what we call standard form. You have a number for A, a number for B, a number for C. Let's check. Are A and B both 0? No. In fact, neither one of them is 0 in this case. So one is 7, one is 14. So you're going to see some things that look kind of like that.
So yeah, basically what that means, the setup's going to be you'll have a number with X plus or minus a number with Y equaling a number. Basically, that's what that means with standard form. Just like slope-intercept, you can have Y equals a number with X plus a number.
Now, I'm not actually going to go and do this one. We're gonna do some later on. But there are 2 special cases, and we looked at them in the warm-up. What's one type of line that you can have that's special? It's not slanted. It's a special case.
Vertical?
Vertical. So if I go back to the warm-up for a second. Vertical line. Right there. Okay? When I talked about it, I said that there was only one letter. Right? Anytime that one of the letters is gone, it's a special case. So let's look at both special cases. Okay, the first one I'm going to show you is Y equals a number.
So just Y, like no X?
Yep, it would look just like this. Right here, Y equals 2, or Y equals -5. There's no X. Okay, so if you have an equation that's like Y equals, I might have one down here, 3. That's a special case because there's no X in it. And Y equals is always horizontal. That's the special case, horizontal. And if you're like, well, where would it be? Y equals 3. That's a horizontal line at the number 3. And I think we have a picture of it. Yep.
Yep.
So here's your axis in black, X and Y. And in red is a picture of Y equals 3.
Now, on your notes, you have 1, then there's a line, right? So you want to write, next to number 1, you want to write y equals 3.
Again, how do you know that's a special case? Just by looking at it? There's only one letter. There's only one letter. Okay? So it's a special case.
Hey guys, one way I think of it is, you'd have a hard time just remembering it. I think of it like this. You want to graph this number on this axis and draw your line opposite of the axis. So if I drew it y equals 3, and I drew it on the y-axis, you wouldn't really see it. It would just blend in. It would just kind of blend in with the y-axis. So I think of it as graph this number on this axis and draw your line opposite. It's one way to do it too, if you can't remember.
All right, so we've got y equals a number. What do you think the other special case is going to be? It's very similar to that.
Opposite. Like no. X.
Just an x, right? We're going to look at the case where it's not going to be just y equals a number. It's going to be x equals a number. All right, so if you've got an equation that's x equals a number, and we did one, I'll just go back to the warm-up for a second. Right here, x equals 2. That was a vertical line up and down at 2. All right? Okay, so here's an example of the other special case. X equals 5. I mean, it could be anything. X equals 3, x equals 1, x equals negative 8. The point is, it's x equals, and then a number. Okay, and like Mr. Roy said, when you graph that, it's x equals positive 5. So you go 1, 2, 3, 4. You put a dot right there, and you draw it opposite the axis. Because if you drew it left and right, see, you can't even tell I drew a line. It just blends right in. So you draw it opposite, up and down. Okay, other than those two special cases, everything else is going to be slanted. All right? And that's what we're going to spend most of the time on.
What's slanted?
Slanted, yeah.
Yeah.
So equations that have both an x and a y, not just one or the other. Okay, but we'll do a couple. I think we've got a couple examples coming up where we'll graph special cases. So y equals, x equals. Okay. Does anyone still need to copy down anything for number 2? Okay. So let's look at that. It says graph the following, y equals 4. Okay, my first question is, how can you look at that quickly and know that it's a special case?
Because
There's what? Bless you. There's no x. You're missing a letter. So special case, in my head, I'm already thinking, all right, it's either left and right or it's up and down. All right. Y equals 4. Does anyone remember which way that one goes?
this.
Yep, which way is that? Horizontal. So it says y equals, what kind of 4 is that? Positive or negative?
Positive.
It's positive, right? There's no negative in front of it. So I go 1, 2, 3, I go up to 4 on the y-axis. And then I draw my line opposite, right? Because if I drew it vertical, you wouldn't even see it. Right? You can't even see him doing it right there. So I'm going to draw it so you can see it. Just like that. And that's it. So the special cases, even though they're a little different, they're actually easier to do. I think they're faster. All right, so that's y equals. Let's take a look at x equals. All right. Savannah, how do I look at that and I know that it's a special case? There's no y. It's missing one of the two letters. Okay. So I know it's a special case. Now I just have to remember if it's the horizontal or the vertical. So Nate, how would I draw this one?
It would be horizontal.
All right. So you're gonna put this number where? You mark -2 on which axis? The x-axis. So this is the x. This is the y. So I'm gonna mark -2. Now if I drew it horizontal, like this, would you see it? No, you wouldn't even see it if it was horizontal. So you got to draw it so you can see it. So good job. It's going to be vertical. And if you had something like a decimal, like if it was x equals 1.5, you just estimate it the best you can. Go in between 1 and 2. I mean, you're never going to have anything that's that strange, but you could have like half or something like that. Okay, so that's the other special case. Any question on graphing that one? And that's pretty much it. That's it for special cases. All right, so if you want to draw a line, if I put a single point like that, how many lines go through that point?
1.
Okay, I can put one like that. Could I do a different line that goes through that point?
Yeah.
It goes straight down.
I could go straight down.
Anything.
Really, anything, right?
It's like a pizza.
There's a bunch of them. So, if you just have one point, that's not enough. Now what if I did this? How many lines go through both of those?
A lot.
A lot?
Well, I mean, like one, and then like if you want to do another one, you can.
All right. So if I go through both of them, I get that. Is there a different one that goes through both of them? Being on top of it, again, is the same thing. Is there a different one that's not on top of that one that goes through both? Gigi? No. So if you have 2 points, 2 spots, and someone says draw a line through them, there's only one. All right? So how many points do you need to draw a line? At a minimum, you need 2. So what we can do is we're going to use this idea to graph lines in standard form, and we're going to find 2 special points. Right? We're not just going to find any 2 random points. We're going to find 2 special ones. And does anyone have a guess what number we're going to plug in to do that? And we did it in the warm-up. 0. That's exactly what we're going to do. We're going to plug in 0 for either the x, well actually both, the x and the y, and we're going to find 2 special points.
Alright, so guys, like Mr. Hager said, today is really the only day that we're going to look at that standard form, like the number x plus number y equals number. Today will be the only day we really look at that. But again, this is another standard form. It's another way that you can graph linear functions. Alright? So like Mr. Hager said, since we only need 2 points to draw a line, we can use this idea to graph equations in standard form. This is only going to work when they're in standard form, right? Number x plus number y equals number, like that. A, x plus b, y equals c. That's what this is. All right? So it's got to be in that format, right? Y equals mx plus b, that's a totally different thing. We'll talk about that tomorrow. All right? So, to graph equations in standard form, we'll need to find both the x-intercept and the y-intercept. All right? How do we do that? So, just remember that x-intercept, just like the y-intercept, the x-intercept is where the graph crosses the x-axis. Remember, the x-axis goes across. So whatever number on that x-axis where your line crosses, that's going to be your x-intercept. All right?
Can I show something real quick?
Sure.
Because I think we're gonna. Okay. Go. I'll show it after.
You okay?
Yeah.
And then obviously the y-intercept is where the graph. We've talked about that before. You guys have probably x-axis is probably. X-intercept is probably something you're not super. You haven't heard it before, but it means the same thing. Just like the y-intercept is where the graph crosses the y-axis, the x-intercept is where where the line crosses a number on the x-axis. All right. So you wanna?
Yeah, I just want to show something. Real
Okay.
quick. It's going to be kind of tied into the next thing.
Okay.
So does everyone have that second part? Y-intercept is where the graph crosses the y-axis. All right. So I'm going to look at a bunch of points that are all on the y-axis for a second, because I think that's the first one we're going to do, right? Oh, x-intercept. All right. So let's look at some points that are on the x-axis. And I want you to see if you notice anything they all have in common. Let's look at this point. What's the coordinates of that point?
0.
Yeah, Ellie?
0, 1.
1, 0.
1, 0. Yeah.
Let me go left to right first.
All right, let's do this one. What's the coordinates at that point? These are all on the x-axis. -3, 0. All right, let's do one over here. What's the coordinates of that one? 7, 0. What do you notice about all those coordinates?
0
0 where?
on the
0 for the y value. 0 for the y value. 0 for the y value. They all have 0 for the y value on the x-intercept. And that's exactly what Mr. Roy is going to show you next. To find the x-intercept, you're using this number 0. Why? We just showed you. They all have a y value of 0.
0. That's when we want to find that x-intercept. When we're given an equation and we want to find, it's going to be in standard form. So when we're given an equation that's in standard form, right? We want to find the x-intercept. We're going to plug in 0 in for y, and that will allow us to solve for x. It might seem a little confusing. You guys kind of did that in the warm-up. It may seem a little confusing right now when you don't actually see an example, but we'll do one. All right? So what about when I want to find the y-intercept? How do I do that?
just do like that.
What do you mean, Yusuf?
Like, instead of like dividing y, so plug in 0 for x.
Exactly. So, like Yusuf just said, to find the x-intercept, plug in 0 for x and solve for y. Alright? That's all I'm going to do. When I'm given an equation, like I said, it's going to be in standard form. I'll plug in 0 for x, and that'll allow me to solve for y. Alright? Say, did you leave that graph up?
Yeah.
Is it the next page?
On the next page.
It's like Mr. Hager just did, right? If I graphed, say I graph this. What's that coordinate?
Can we like use this like 2a?
1, 2, 3, 4, 5. So it'd be 0, comma, 5. If I was doing this one down here, what would that be? 0, -2. Just like we showed you before. Which value is 0? The x or the y? Yeah. No, not the y is 5 and the y is -2. The x, right? Remember, it's just like alphabetical order. X is first. They're both 0. Just like we talked about. Plug in 0 for x, that will give you y. Alright? So everybody has this, right? We're good with that? Oh. Let's look at an example. Alright, so 2a says, you guys have the directions, you just don't have the equation. You have to write the equation. So use intercepts to graph the equation. Label the points corresponding to the intercepts. All right, so let's solve we'll solve for the x-intercept first. So when I solve for the x-intercept, what do I have to do?
Plug in like 0 for y.
Plug in 0 for y. Alright, so let's write this equation out with 0 plugged in for y. Someone want to tell me how to do that and what I'm going to write, Yusuf?
3x.
3x?
Plus 4 comma 0 equals 12.
You meant parentheses, right?
Yeah. Sorry.
Alright, so at this point, guys, it's up to you what you want to do. Alright, there's a lot of things you can do. You can do 3x plus, don't write this down, you don't have to write this.
That's what it is.
I want you to write this
Yeah, I did right.
with it plugged in, but the next thing, it's up to you how you want to do it. Alright, we can say, yeah, 4 times 0 is 0, then have the 0, but I think some of you guys will say, okay, then I got a minus 0, 3x equals 12. I think it's going to might confuse you and make more steps that you don't really need. So that's one way you could look at it. Another way. What I like to do is, I know that this is going to become 0. I don't really need it. So what I do is, I just do 3x, I cross this out, because I know it's gone. Because with this, right, what I did before, I think a lot of people will do this. Then you're like multiplying it out to 0, then some of you guys are going to think, well, then I'm going to minus 0. And you're going to do all this extra work. I mean, it's not really extra work, it's just extra writing. So what I like to do is, I know this is going to be, you just saw it right there, we know this is going to be 0. It's just gone, it disappeared, it doesn't matter. So that's why I'll plug in 0, and I'll just cross it out. Cross out the sign with the number, and cross out the times 0. I just cross it all out, that way you're saving yourself all that writing. Now, I'm at one more step. What's the last thing I have to do, Dylan? What I have to do here to solve for x? This means 3 times x. So I'm going to get rid of it. Divide by 3. Good job, buddy. Divide by 3. Divide by 3. X is going to equal what, Dylan? Not sure. Somebody help out Dylan for me. Savannah, what's x going to be? 4. Alright? So x will equal 4. So that's going to be my x-intercept. Now, I'm going to solve for my y. Y-intercept. Somebody want to tell me what I should write? What am I going to write this time? I just solved for the x-intercept. Now I'm going to solve for the y. Matt?
You're going to put 3 times 0.
Okay.
Plus 4y equals 12.
There it is. What am I going to do to that 3 times 0?
Make it a 0.
You can make it a 0. What did I do in the last one?
Cross it out.
Just cross it out.
So then
If you want to put 0, you're not wrong. I just think you're making yourself some extra writing that you don't really need. Alright? What am I going to bring down?
4y equals 12.
4y equals 12. I could bring that plus down if I wanted to, but I know if there's no sign attached to the left, I know it's positive. One more step. What is it?
Divide
Divide by what?
4.
Drop out. Divide by 4. Divide by 4. Y equals what, Ellie?
3.
3.
The y-intercept will be 3.
Y-intercept will be 3. X-intercept will be 4. Alex, how am I going to graph this? X equals 4. Which axis will I be graphing on, the X or the Y? What's that, buddy?
Vertical.
No, which one's the X-axis? The one that goes across and one that goes up and down? Across, right? Where's 4 on the x-axis? On the right or on the left? How many over? 4. 1, 2, 3, 4. Like I said earlier, I know it sounds like I'm repeating myself like a broken record, but graph this number on this axis. Again, it's not asking us to graph that line, it's just asking us to graph that point. So graph, again, this number on this axis. Now, what coordinate is that? What coordinate is that, Ellie?
4, 0.
4, 0, right?
4, comma 0.
4, comma 0. And think about it. To get the x-intercept, we had to plug in 0 for y. So whatever thing you're plugging in 0 for, whether it be the x, if it's for the x-intercept, your y coordinate is going to be 0. If it's the y-intercept, your x coordinate is going to be 0. That's all it's asking you to do is just give us the coordinate. All right, now my y-intercept. Brady, what's the coordinate for my y-intercept going to be?
3.
All right, is the 3 going to be the first coordinate or the second coordinate? Because the 3 is the y. Good. And then my first coordinate, my x would be what?
The first word?
Yeah. What did I plug in to get that 3?
Y.
I know it's y. What did I plug in for x to get y as 3? Look at what I'm pointing at.
0.
0, right? So remember, y-intercept, your second coordinate is going to be 0. Y-intercept, your first coordinate will be 0. It's whatever you plugged in to get that number, whatever you plugged in for 0, make sure you put that in that coordinate. All right? So 0, 3. I got to graph this. How do I graph y equals 3? Someone tell me. Chris, how do I graph y equals 3?
You go 3 up the vertical.
Go 3 up on the vertical line, right? Graph this number on this axis. There's the y-axis. There's 3. Now, all I'm going to do now is connect the dots. There it is. So again, that's how we graph using intercepts in standard form. All right? The biggest thing is make sure you put the actual coordinate for the intercept. Like I said, if it's the x-intercept, the first you'll have a number, second coordinate will be 0. For your y-intercept, first coordinate 0, second coordinate is a number bigger or smaller than 0, depending if they have a positive or a negative. All right? So get another one. Same deal. Same exact thing. So we'll go, and again guys, you don't have to label when you're solving for the x-intercept and the y-intercept. I'm just doing that so you guys can recognize the difference from one to the other. Alright, so my x-intercept. Somebody tell me what to write. I'm solving for the x-intercept. Matt?
2x minus y times 0 equals 4.
2x minus, do I need the y?
No.
No. Remember, wherever I'm solving for the x-intercept, wherever y is, it's going to be 0. This one's a little bit different because the one I did before had a number attached to the y. This time, I don't. I just have the single variable of y. I'm just going to put 0 equals 4. What can I do now so I don't confuse myself? Remember, Matt?
Get rid of 0.
Yeah, I'm just going to, again, for me, because I think some of you guys, like I showed you before, will do like plus 0, plus 0. You're going to make more work for yourself. As soon as you get that 0, whatever's with it, whatever sign's with it, whatever number's with it, attached to it, just cross it out. What am I left with, Ryan? When I cross out that 0, that minus 0, what am I left with?
2x equals 4.
2x equals 4. Do you know the last step, Ryan?
Divide 2 by both sides.
Divide by 2. Nice job. What do I get? X equals 2, nice job. Ryan, do you feel comfortable enough graphing that? Could you tell me how? Okay,
Positive 2 to the right, and the x-axis.
good job. Ready for that too. Ryan, do you know what coordinate that is? Like something, comma, something?
And then 0, 2 or something. And then 2, 0.
2, 0, you got it, perfect. 2, 0. Remember, x is first, y is second. Alright? So we're going to solve for our x-intercept. How about, scroll up a little bit. Paige, could you tell me how to set up the second one to solve for the y-intercept? 2 parentheses 0 minus y equals what? 4. Alright, so again, I'm just going to cross out whatever's with the 0. Now be careful here. Because you're probably thinking to yourself, well, I got y by itself now, I'm done. So I'm going to bring down what's left. What's the matter with this? Matt?
The y is negative.
The y is negative. So is y really by itself? No, what's attached to the y even though we don't see it? A negative 1. What do I do to get rid of that, Matt?
Change the y to a positive and change the number to a negative.
Okay, so I'm gonna divide, right? I'm gonna divide by what number?
1.
Careful.
Negative 1.
Negative 1. Alright, so don't get tricked on this one, right? There's still a negative 1 attached to that y, even though you don't see it there. So my final answer is gonna be y equals what? Everybody know? Negative 4. Good job, Chris. Y equals negative 4. Laurel, how would I graph that? On what axis? The y. Am I going up or am I going down? Down how many? 4. Nice job. 1, 2, 3, 4. Laurel, do you know how to label that coordinate? Like our x-intercept was 2, 0. What about for the y-intercept?
Negative 4, 0.
Careful. Close. Flip it.
0,
0, negative 4. Alright, I got that. I'm going to get my line. Hey, pardon, that's okay. And there it is. Again, that's how I graph using intercepts. So, the people that's going to be, I know Mr. Hager will fix it, he's a perfectionist. Alright, for the biggest thing is, you guys having a little bit of hard time with being able to label the intercepts. Again, just think, what did I plug 0 in for to get the x-intercept? I plugged it in for y. That's why the y is 0. What did I plug in for 0 to get the x-intercept? I plugged in 0. Alright, whatever intercept it's asking for, the other letter is 0. Like in this case, it asks for the x-intercept. X has to be a number greater or less than 0, and then y is going to be 0. Y-intercept, we have to have a number greater or less than 0 for my y, and then the x is just going to be 0. Alright? That's it for that stuff. I think that might be... Oh. Okay. You are planning an awards banquet for your school. You need to rent tables to seat 180 people. Tables come, I should say come. Oops. Fix it. Tables come in 2 sizes. Small tables sit 6 people, and large tables seat 10 people. The following equation models this situation. So there's your 6, right? Again, 6 people, you got to see how many tables you need. That's why the tables are X, right? The smaller tables. Larger tables, you got to see how many you need. That's why y is, that's why the larger tables is y. All right?
Kind of understand what's going on? You get different sized tables, you gotta seat 180 people,
Yeah.
so you can have a mixture of small tables and big tables.
Yeah.
Or all small tables and maybe all big tables.
Like we just talked about, x is the number of small tables, and y is the number of large tables. And you don't know how many you need. That's what we're trying to figure out right now. All right? So now, say it's just a word problem, all right, but we're doing the exact same thing. It says graph the equation and interpret the intercepts. All right? So graph the equation. Before we can graph it, what do we need to figure out? Just like we did the last two problems. Example 2a and 2b. Before graphing in standard form, what do we have to? We have to figure out two things first before we can draw our line. The x and y intercept, right? Just because it's a word problem, guys, it's the same exact thing as what we've done before. It's just written as a word problem. So let's solve for the, we'll do the x-intercept. I'm sorry. Let's solve for the x-intercept first. How do I do it? Yusuf?
So you can put like 6x
Yeah.
plus 10
Yeah.
column, I mean not column, parentheses.
Yeah.
You have to do that. 0
Yeah.
equals
180. Like I said before, you can do the 10 times 0 equals, do the 0, do all that stuff. What I do is, I just cross it out. It's less writing. I'm going to cross out the plus sign, the 10, and the 0. That's all gone. What am I left with?
180 divided by 6.
Okay, so I'm going to have 6x, like Yusuf, he's right. I'm going to divide by 6. Divide by 6. X equals, let's see.
So it has to do something like
180 divided by
30.
6. 30.
oh, we're scholars.
So x equals 30. So I just figured out my x-intercept. All right? Let's do my y. Jake, when I solve for the x-intercept, I make y 0. What about when I'm solving for the y-intercept?
X0.
Make x 0. Do you know what to write? Can you tell me? If we're making x 0, here's the equation we want to use. And you just told me to solve for the y-intercept, you make x 0. So do you know what to write?
6,
Yeah?
0.
6. Can I put parentheses?
Yeah.
Okay. Parentheses, good.
Plus 10y
Plus 10y. Agreed?
equals 180.
Equals 180. Very good. All right? What can I do to the 6 and the 6 times 0? What have I done every time? Crossed it out, right? What am I left with, Jake?
10y equals 180.
10y equals 180. You know the last step? Just like we did over here. What am I going to do?
Divide.
Divide by what number?
10.
Nice job, Jake. Now on a Monday morning, Jake, I'm not going to make you do 180 divided by 10. But your answer should be. All right. Y equals 18. So there's your two intercepts. X equals 30. Y equals 18. All right. So basically, to say when we write interpret the intercepts, do we mean what coordinate it is?
In the context of the word problem, what the coordinate would be.
Okay. So let's get a. I'm saying I'm gonna grab one.
Where is x?
All right. So now, let's go by. I don't know. We'll go by. Let's see our axis is here.
2 on the y-axis, maybe?
Yeah, we'll go by 2 on the y-axis. So we'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then we'll do maybe by 30, maybe we'll go by 3s.
You can even do 5s.
Okay, let's
Go.
go.
It's up to you.
Let's go 5, 10, 15, 20, 25. Alright, so I want to graph the x-intercept first. So what do I do? Ellie?
Go over to 30.
Yeah, well, again, if we give you a word problem like this, guys, like we've done pretty much every time this year, you're not going to have to draw the graph. The graph's going to be already set up for you. It'll be numbered, it'll be all done. A lot of these sometimes, too, for you guys, are multiple choice. So don't worry too much about like numbering the graph. It'll be a multiple choice problem, or if we have you graph it, the graph will be already set up.
And
So I'm just going to do that. Now, what coordinate is that, Ellie?
30, 0.
30, 0. Good. All right. Bethany, how would I graph the y-intercept?
You put on the line of 18.
Yeah, go all the way up to 18. Put a dot. Do you know what coordinate that is? Because for the x, it was 30, 0. What about for the y?
18.
Almost. Flip it. 0, 18. Remember, y, for the y, the 0 is first. All right? For the x, the 0 is second. So it would be, you all set? All right. So we're going to have, like Bethany just told us, oops, I made the same mistake. It'll be 0, 18. All right? So again, graph the equation, interpret the intercepts. That's what we just did. We graphed it, right? And we put the 2 coordinates. All right? Now, it says find 4 possible solutions in the context of the problem.
So we still want to know what 0, 18 would mean.
Oh.
Allie?
0, 18 would mean y.
Y.
So
Okay.
it'd be like y equals 18.
Okay. But what did Y represent in the problem?
Oh, y represented large tables and x represented the smaller tables.
Mm-hmm. So my mistake is right. This would mean having what? 18 what?
18 small table, 18 large tables.
18 large tables.
And having 30 smaller tables.
Okay.
Well, each one is separate.
Yeah.
So 0, 18 would mean having.
Okay. Yeah. So the mistake is saying, guys, because the x is small tables, right?
Yeah.
Yeah.
So for this, how many small tables did you have?
18.
No.
0.
0, right? Because this is your x.
That's crazy. Yeah.
X. Sorry, mistake. X, Y, right? So you could have 0 small tables and what? 18 large. Now what about this one?
30 small, 0 large.
Good. Right? Like Donovan and Nicole just said, you could have 30 small, 0 large.
All of them.
So that's what it means. Like that's what it means by interpreting. Like, what does it mean? Like Mr. Hager said, these 2 things are together. All right? 0 small, 18 large. 30 small, 0 large. Now,
I want to combine it.
we graphed it, right?
Yes.
Kind of goes back to like last week. We looked at the graph and we said, find a coordinate somewhere on that graph. So basically, anything in this range for the x and the y would work as a solution for this problem. So what's one coordinate? Like Mr. Hager's going to put a dot there.
Oh yeah.
So
I picked that one because it looks easy.
yeah, we're looking for nice ones that kind of like go through. Like I call it like the bullseye, like where it crosses like on one of these X's on one of the little, like it's like a small graph. I'm looking where it crosses through there perfectly. I'm not gonna pick this one because it doesn't go through here or here perfectly. I'm not going to pick this one because it doesn't go through there perfectly. I'm not going to pick that one because it doesn't go there perfectly. I'm looking for where it makes a little X with the little grids. I want to find a couple that go through perfectly. It's going to make it easier to figure out the coordinate. So that the red dot that's on top, what coordinate is that?
0.
Remember, we do our x's first, right?
5.
Let's see.
10.
10, right?
That looks like 5.
If I follow 5 all the way up, I'm not going to go through that red dot. It's going to be 10. So how many? So it will be 10, comma. What's the y? 12. 10, comma 12. What does that mean in the context of this problem? Good. Like Nicole just said, that would mean having 10 small tables and 12 large. Again, you're just finding a nice coordinate where it crosses perfectly. That's going to give you one solution. What about this one that's a little bit lower?
That's 20.
So my y would be, like Yusuf said, 20,
26.
comma 6.
I got that one big.
So that's going to mean having what? How many small? 20 small, 6 large.
Oh, I do 4 possible.
I mean, Mr. Hager changed it. Again, we picked 2 because there's 2 nice coordinates. Right? So again, that's how you do that. Go through, solve for the x and y, just like you did before, and then draw your line to the two intercepts you found. Any nice coordinates, that means where it crosses perfectly, any nice coordinates, that's going to be your solution. Or possible solution. There'll be more than one. Alright? Good with this? Alright.
We should skip that one.
Yeah, we kind of did something like that. We're good. So,
Basically the same.
yeah, guys, I'm not going to go through this, but what would I do?
You would, like, just do 0.
Do the same thing, right? If I want to solve for the x-intercept, make the y 0. If I want to solve for the y, make the x 0. Go through. Again, what does it mean? If I got like 0, comma 12, that means what do I have? 0 small, 12 big. If I had like 7, comma 0, that would mean this means I have 0 small, 12 big. What does this mean? 7 small, 0 big. That's all that means. All right. I'm gonna skip these. I'll go to the end. We'll do this after. All right. So, guys, homework tonight. 3.4. It's not super long.
Wait. Can you go down a little? Go down.
Yeah, I'll talk about that in a second. All right. So, guys, believe it or not, because you guys had the double shot week, it's not your fault. This is the way the schedule worked out. Progress reports close on Friday.
I'm chilling, bro.
All right. Progress reports will close on Friday. Remember, guys, like Mr. Hager said, we have no review day this week because we had this 3.6. We didn't do it last year, so we had to add it this year. So that's why we don't have a review day this week. Hopefully, maybe next academic week we may have a review day, but again, we don't have time for one this week. Guys, remember that test you got back today from Mr. Hager.
Yeah.
That'll be on your progress report.
Oh, God.
All right. The one from this upcoming Friday will be on your progress report as well. So again, you really want to make sure. Now, guys, for me, football is over. I'm done. It was done last Wednesday night. So Thursday, I will be here. Thursday after school, I will be here. I can stay till 4 o'clock. Today, I'll be after school. I can stay till 4:45, 4 o'clock. All right, so if anybody needs to stay after school today, I'll be in my room. My room's right across from Cosmo 225. And I know some parents of you guys at Parents' Night said that a lot of you guys are going to start staying on Thursday so you can review for the test. that's fine. I'll be here on Thursdays, now like I said, till 3:45, 4 o'clock. Alright, leave your, I think someone asked when grades close for the quarter. That's not until like January.
After midterm.
Before midterm.
Yeah, before.
Right, guys, remember, your midterm exam, that doesn't count for like second quarter. That's like a standalone thing.
I know
That's worth 10% of your final grade. Remember, your final grade says whether you pass the class or not and get credit. Alright? Yeah, so we're not until January when grades close. I think, this year, am I correct? Only one more academic week before Christmas break for these guys?
Oh, yeah.
I think I'm correct.
Really?
Guys, so there's only one, so before we leave for break, you guys will only have had 3 test scores. The one from a couple weeks ago before you guys did the double academic week. You'll have the test from this Friday and then from next academic week. Alright, so you want to make sure this quarter is really spread out. So you want to make sure you put the time in this week and get a good score on the test on Friday. Leave your notes out. Do these. Yes.